we're going to begin the solutions to this set of problems, and we're going to start with where we were before, which is with a free body diagram. So I'm going to have the normal force on this box from the surface that it's on. I have its weight. I have this force here, and I'm just going to highlight that we have a vertical and a horizontal component that I will label like this. So we have Fy equal to F times the sine of theta. And we're going to have a horizontal component Fx, which equals F times the cosine of theta. Now we want to know the magnitude of the block's acceleration. So let's just set that up for part A. We know that F cosine theta equals m times a. And so that's going to give us F cosine theta divided by m equals a. And I can go ahead and put in my number, so I can put in 12 newtons. I have the cosine of 25 degrees. And I'm going to divide that by the mass that I have, which is 5 kilograms. And that's going to get me my acceleration. And so when I'm done, that will give me an acceleration of 2.2 meters per second squared. Great. Now it says the force F is slowly increased. What is the value just before the block is lifted off the floor? And just to be clear, what that means is that if it's just before the block is lifted off the floor, what that tells us is that in this case, for B, that would mean that Fn equals 0 just before leaving the floor, because it's not touching the floor. So what that tells us is that Fy times the sine of theta, Fy minus Fg would equal 0, because they still balance. And what we're going to get is that Fy is going to equal mg, and that means the force itself, F sine theta, equals mg. And so F is going to equal mg divided by the sine of theta. So let's go ahead and put in that number. That's going to be 5 times 10 divided by the sine of 25 degrees. And when we get that number, that's going to give us 118 newtons of force. Now we want to know the magnitude of that acceleration before the block is lifted off the floor. So let's try the following. We know that F cosine theta equals ma, but I'm going to do something a little bit different here. I got that F equals mg over the sine of theta, so I'm going to get this as mg over the sine of theta times cosine of theta equals m times a. The m's cancel, and so I'm getting that g times the cotangent of theta is the acceleration. So my acceleration is going to equal 10 times the cotangent of 25. And when I solve that out, I'm going to end up getting an acceleration of 21.4 meters per second squared. All right, so that's question number 1. We'll take a look at question number 2 in the next video.